Okay, so let's start. Good morning. So everyone who didn't connect in Zoom with their first and last name, next time use your first and last name. So some people have only one name. So just for taking attendance, make sure you have both your first and your last name. Okay, so before we start with lesson 2, let's look at the homework from yesterday, lab 1. So 3 questions here. First, why is software architecture important? Well, it's about quality of your system. So without proper architecture, without a good quality, your system, difficult to build, difficult to test, difficult to maintain, difficult to change, difficult to understand, difficult to reuse, difficult to integrate with other systems, etc. So everything you do in software, you want to do it with the highest quality. So there's always the trade-offs between costs and quality. Because the more quality you put in your application, typically the cost goes up. And the time that you need to build the system goes up. Well, in general, every time you build something not of a high quality, that might be fast and cheap in the short term, but will always end up in expensive in the long term. So it's better to invest right now in good quality than later have to maintain and change, etc., a crap system that you build very quick. And that's why in a traditional project, we have an architect and a project manager. The project manager wants to have everything done as quick as possible because that's the cheapest for the business. The architect wants everything to be at the highest quality. And then typically you have a sort of trade-off in the middle. And in an agile project, you actually have the same. The product owner wants to have everything as fast as possible because it's the cheapest for the business. The architect and the team takes care now, whatever we build, we do of the highest quality. Then the second question, what's the difference between software architecture and design? That was already also a question during the lecture yesterday. Software architecture oversees the whole. It deals with all the requirements from all the stakeholders. So it's typically at a higher level, while design is more at a point level. I need to design this small thing, or I need to solve this small technical problem. It's typically design. So design is typically at a more detailed level and often doesn't oversee the whole. Like the example that I give with the designer might think, or the developer might think, okay, I'm going to use a cache here. While if we look at the whole, then our system should be scalable and we do clustering, and then you don't want to use a cache. And architecture is design. Design doesn't need to be architecture. Then the third one, what makes software architecture so difficult? Well, first of all, there are many decisions you have to make. So yesterday we had this whole list. Which database do I use? How do I go to the database? How do I do transactions? How do I do security? How do I do the front end? Which framework do I use? How do I do Which language do I use? Which frameworks do I use? Which patterns and styles do I use? Which libraries am I going to use? How do I distribute it? How do I integrate it? Which protocols do I use? Many, many decisions you have to make. And not everybody is expert in all these levels. Every possibility has advantages and disadvantages. There's no silver bullet, there's no ideal architecture. So it's about making trade-offs. Everything changes all the time. And don't underestimate this. Software developers don't like to work on one technique or one framework or one library for a long time. So you might think that in an organization, we choose this development stack. Let's say we do Java EE with Angular in the front end. We use SQL Server as database. We do this for messaging, and you have this whole stack. And you start working for that organization, and you learn about the stack, and in the beginning it's all learning, and then you apply it, and then after 2 years you're the expert, and then after 3 years, well, you've seen it all. You know all the things. So after 4 years you think, well, I'm not going to do this for another 5 years. And then you start looking around. Maybe I should go to another company where they use new things, different things. So often organizations have to change to keep the developers on board, to keep the developers, the software engineers, interesting. We change because the software developers want to change. That looks very weird, that like in the automotive industry. You never would do that. You never would build a new car because the car builders are fed up with the old car. You just don't do that. It's all about making money, and if you have a good car that sells good and all the customers like the car, then you build that car for 10 or 20 or 30 years. As long as customers like that car, you build that car. You don't care about the people who have to build the car. That's specific for software. Okay, so that was this lab. So I also posted a recording from yesterday. So it takes me some time. I recorded with Zoom. And when I'm done with the presentation, Zoom needs a lot of time to process the recording so that it becomes an MP4. So typically the next day I post the recording of the day before. Now for today, we're going to look at layering and Spring Boot. So remember what I explained yesterday. The first lectures are about the architecture of one application. Build one application. Later on, when we go to microservices, we build multiple applications and we have to connect them together. That's for later. So one of the architecture styles that almost all applications use is layering. So that's why we start with layering. What is layering? Layering is basically dividing something complex up in multiple simpler parts. So that's a key architecture principle. It will be all at the end of the slides. Key architecture principle: whenever you have something complex, you divide it up in multiple smaller, simpler parts. That's a key principle. And layering is an example of that. Instead of having one big spaghetti system with all kinds of classes and they all talk to each other, I separate it in layers. And now I see here, let's say 5 or 6 layers. So instead of having one big complex thing, I have now 5 or 6 smaller, simpler things. There's also separation of concern, that typically you hide whatever is in a layer. Layering is also often used in networking. So if you study computer networks, there are different layering schemes. But one of the layering schemes is the OSI 7 layers of networking. And what they do in their layering scheme is as follows. That in networking, you have all these different layers. That a layer only knows the details of the layer below. That's one of the principles that they apply in networking. You typically don't apply that in software. I will explain that. So the second layer only knows about the layer below, but nothing else. The third layer only knows about the fourth layer, but nothing else. So you hide details. Like the top layer, you hide basically all the lower layers here. The top layer doesn't know these lower layers. It only knows the layer below it. So it's separation of concern. In the layers you do different things, different functionality, and you hide things from each other. And what does that give us? Loose coupling. Seen that yesterday. Layers are independent, so loose coupling. And you can, typically you don't do that. You can distribute the layers. That maybe the web layer and the service layer is on one system, and the business logic and integration and the data access is on another system. You could do that, but typically you don't do that. It has to do with performance. We will see that later. And typically in layers you use different techniques. Going to the database is a completely different technique than calling another system or the web layer. Now, which layers do I need? Well, there are many layering schemes. Sometimes you say, well, a 3-layer architecture here. Presentation, business or domain layer, and data access or persistence layer. That's possible. Here is a 4-layered architecture. Presentation or user interface, service, business domain, and data access. You could have also a 5-layered architecture, a 6-layered architecture. Now, from the theory, you can have closed layers and open layers. What's a closed layer? A closed layer is that a top layer, let's say here the presentation layer, can only see the layer below it, but that layer below it is closed. So you cannot look, the presentation layer cannot look past the service layer. It's closed. And the service layer can only see the business layer, but nothing else. Cannot see the data access layer. This is typically what you do in networking, but not in software. So typically in software we have some layers are closed, some layers are open. So here you see the business layer is open, meaning the service layer can directly go over the business layer, call the data access layer. Does the layering principle relate to the principle of least knowledge, law of the meter, knowing only about the next layer? Well, it looks about it, but law of the meter really talks about objects. and here it's objects and classes. So the underlying principle is the same, but it's different. Now this is typically what you do in software. And I will explain the details later when we look at real examples. But the presentation layer only sees the service layer here. What's the service layer? The service layer is the logic that you apply to the outside world, that you expose to the outside world. The things that you can do with this application. It's a service layer. I'll come back on it to make it more clear. And then we have the business or the domain layer. What's in there? Business logic, domain classes, classes that are not technical. So in a bank system, bank accounts and customers and transactions are in the domain layer. Here's the business logic. In a library system, the books and the loans and the reservations are here. In a car rental application, the cars and the rentals and the payments are here. Business. Data access layer or persistence layer. Here we find all the logic that you need to go to the database. Where is the database? What do I send to the database? All these kind of things, transactions on the database. And the integration layer is all the logic that you need to call other systems or to send emails or going outside your system. Now, what you see is that the service layer talks to the three lower layers. And actually a better picture, it's the same picture, but a better one is this one. It's exactly the same picture. The important thing here is, if you look at the arrows, who can call who, is that in the middle, or in the center here, is my business logic or domain. That's the heart of my system. And there's no arrow going out of the business logic. So data access here, that's technical code. So what SQL do I send? Transactions, open connection, closed connection, committed transaction, handle exceptions. That's all in data access, that's technical code. Integration is technical code. Calling through a web service another system, sending an email, writing something to the log file. It's all technical code. Now, the idea is that the business logic, that's not technical code. It's business code, business logic. That's the difference. And actually, you don't want that the business logic code knows anything about any technical code. The business logic code should be completely independent from the database, from logging, from security, from anything that's technical. That's the best practice. Why? It has many advantages, because then it makes this business logic easy to understand, to write, to test. If you change from database, the business logic doesn't need to change. If security gets to do it differently, business logic doesn't need to change. If you want to log in a different way, business logic doesn't need to change. So we get separation of concern, and it gives us loose coupling and flexibility in our application. Now, who connects everything together? That's the service layer. So what I said, later on, we become concrete with real classes in the different layers and how it works. And the presentation layer only knows the service layer, that's all. So there we get information hiding, etc. Loose coupling between the presentation layer and the layers below. Now, so this is a layering scheme that's used a lot. Is this the only one? No, other people use other layering schemes. So for example, logging. We have a log file that logs something. Log4j or whatever. Where does it belong? Well, it's not data access. Is it integration? It's not service, it's not presentation, so it's not business logic. So integration actually is the only place to put logging. So some people, they put data access and integration together and they put it in, they call it the infrastructure layer, all the technical stuff, infrastructure, call it typically plumbing. And within the infrastructure layer, you can have sublayers or packages. Then I have database access and integration. So what about controller? Do we have a controller layer? No, the controller goes in the client layer. So first of all, it depends what you mean with a controller. Typically, it's a controller in a web application. So that's either a REST controller or for a web application, you just have a controller. Like if you use Spring MVC or whatever, you have a controller there. Looks a little bit different, but the controller is typically in the client layer, the web layer. So, and again, we will look at an example where there is a controller in the web layer. So, benefits of layers, the most important one, separation of concern. And I didn't put that here, but loose coupling. Not between all layers, but some loose coupling. So different skills for each layer. So that makes it easy to modify, easy to test. You could distribute the layers, but that's normally not done. And the drawbacks is, well, you have to write all these layers. If I have a very simple application that gets something from the database and returns it, then I could do that just with one class, with one layer. That's the most simple. But if I follow this principle, then now I get 5 layers. Is that really necessary for this simple application? Well, I would say if the application is so simple that it is just 5, let's say 3 to 5 classes that only they get a call in and they go to the database and they return whatever they have, and the classes have maximum of 10 methods. The methods are very small, maximum of 10 to 15 lines of code, then you don't need layers. But what mostly happens then is most applications grow over time. They become more and more complex. And now we get this exception, and then we get this business rule, and then this goes to another database, and then here we have to call another system, and here we have to send an email, and that's typically what happens with these systems. And then you want layers to. So again, the moment it becomes complex, the first thing you do is use layers to have multiple simpler layers. Performance can become an issue. I'll come back on that, but typically not. Well, maybe I should explain it right now. I saw somebody once at a conference and he explained it very nicely, and I'm going to use that. I always use that because I like the way he explained it. And it was in a conference in Belgium, and it was an American person. And for some reason, American people like the Belgian beer. So the example he used was about pubs and beer. I should not promote that, but I just used the example. Let's say every Friday night, you go with your friends to a pub to drink some. Well, let's not use beer. Let's use orange juice. You're gonna drink some orange juice together, and to go to that pub, it takes you 20 minutes on bike. So I have an object here that calls another object here. Let's say this is a Java object within the Java virtual machine. So local, could also be a .NET within .NET, but one object calls another object. And that's 15 minutes to make that call within the virtual machine. And then at that pub, you meet a friend, and that friend says, I've been somewhere, they have such a good orange juice, you really have to go there. Okay, where is it? It's on Pluto. So Pluto, so now in software, this is another virtual machine, typically on another server, somewhere on the network. To go to Pluto is 14 years in a spaceship to get there. So maybe you get a ticket, either with Jeff Bezos or the other guy from Tesla. But you buy a ticket, you're convinced I have to go there because I like orange juice. And after 14 years, the ship, you look outside the window, you see there the pub, nice neon lights. And when you go in that pub, you're gonna drink orange juice completely different than you do normally. Either you drink everything they have, or you take everything with you. But it's not like, okay, give me one orange juice and you drink it up and then, oh, that's good orange juice. My friend was correct, it was good orange juice. And he said, okay, goodbye everybody. I will be back in 28 years. You don't do that. Now, this is the difference between an in-memory call within the virtual machine or a remote call somewhere outside the virtual machine. So the idea here is if I have different layers, then one object calls another object in another layer, that one calls another object in another layer, and that one returns to another layer, and then that calls another one in another layer. Is that not very slow? What if I have just one object? That must be faster. Yeah, it is faster, but you don't see the difference. Why? Because if you have a web application, here's your browser, and the browser goes to a server somewhere. That's a call to Pluto. Let's say the server goes somewhere to a database. That's a call to Pluto. And then the result comes back. That's another 14 years. And then the result comes back. So that's 56 years. Does it take? I press a button on the website to get the answer back. Now, do you see the difference between 56 years and 10 minutes? Oh, sorry, 56 years and 15 minutes? Or 56 years and 150 minutes? No, you don't see that difference. So whenever you have a performance issue, the first thing you always need to look at is remote calls, not in-memory calls. like there are too many objects that call each other. That's typically never your problem. Only if you do that in a loop, and you do that maybe 1,000,000 times, or maybe 100,000 times, then it starts adding up 15 minutes times 100,000 times, then that goes into the seconds for software then. But so in general, this is never an issue, objects calling each other. That's why it doesn't matter if we have 20 classes, 20 objects, or 2 objects related to performance. Now for layering, you want separation of concern. You want loose coupling. So what you don't want is here on the right side, here, that this top layer, the classes in the top layer, and they are now depending, tight coupling with all the classes in the layer below it. So what do? You put a class here, 1 or 2 or 3, we'll look at how that works, but you don't want, you want to hide the internal details of this layer. So you put a class on top of it, and everybody on the top layer depends only on that class and not on all the other details in the layer. This is typically where the service layer comes in. Again, we will look at an example here. So the main thing of layering is separation of concern, making something complex simpler. Different skills, information hiding, loose coupling. That's why I do it. Well, life is found in layers. Whole creation is layers. From simple, typically from simple to complex. So you see layers everywhere. We also use layers in our daily life for encapsulation. Like we hide between things behind a layer. So for example, in a car, there's an engine within the car. You don't see the engine, only when you open the hood, but you don't see it, but you don't need to see it when you want to drive a car. So the engine is encapsulated in it. You see, when medical people study the human body, there are different layers that they study. Some medical people or people from physics, they go very deep in the lower layers of creation, while others more study the more higher layers of creation. Okay, so first thing was layering. Then we're going to combine layering with a number of architecture patterns. So typically layering, you could call it a pattern, but it's typically a style, an architecture style. What architecture patterns do we have? Well, one is a data access object, also called a repository. It's a class that knows all the details to go to a database. So if we have a customer in our application, we typically have a customer data access object, a customer DEO, or a customer repository with the methods save a customer, update a customer, delete a customer, find customer by customer number, find customer by name, find customers by name, those kind of methods. It's in a data access object. So within object orientation, you want Also separation of concern, single responsibility. So the customer DEO, the customer repository, knows how to put a customer in and outside the database. And the same idea we can apply to any technical class. A class that does logging, a class that sends an email, a class that sends or receives messages, a class that does a remote call, a class that calls a web service, whatever technical you want to do, class that goes to the file system and reads or writes to the file system, you write it in a separate class. That's single responsibility. That class is responsible for file access, or for logging, for sending an email, doing a web service call. And then, so we have a repository or a data access object. We have technical plumbing classes. And then we introduce a service class. And the service class is typically in the service layer. So what's this service class? Here I give an example. So this is a very small bank application where you can deposit and withdraw and transfer funds between accounts. So the way it works is as follows. The client goes to the service and says, deposit $100 on account 312. The account service calls the account DEO and says, load account with account number 312. It goes to the database, it gets back data, it puts that data into objects, and what it returns is this account object, which has a list of account entries. What is an account entry? That's one line in your account statements. One statement in your list of statements. So if you go to your account, either on paper or online or whatever, what you see is a number of transactions that you have done. Yesterday I got so much money. The day before I paid this bill. And then this time I paid this. There are account statements. I call it here account entries. A certain amount on a certain date with a description, etc. And you have many of them. One account has many of them. And this part here, this is the business logic here. Here are the business rules. So the deposit calls the account DEO, give me the account with number 312. It returns the account object, and deposit now calls deposit in the account object. Here's the business logic. What does deposit do? Create a new account entry, the date of today, the amount is $100, maybe there's a description, and add it to the list. That's the business logic. Then it returns. And then the account server says, okay, let's update this account to the database. So you call update with the account, and it updates it into the database. And then maybe it says now, okay, send a message. Here's a GMS message, but it could be an email message or whatever message. Send a message to the account holder. Send a message to the text service if the amount is bigger than whatever. So if the account DEO returns an account object, why there is no dependency between the two classes? Actually, there is only in a class diagram. We have an association and we have a dependency. An association is a fixed line. A dependency is a dashed line. Typically, dependencies you don't show. So what's the difference? An association, if, let's say, the account service and account DEO, they have an association, fixed line, meaning that the account service has an attribute of type account DEO. There's an attribute in there. similar as between account and account entry. An account has a list of account entries. It's an attribute in account. It's an association. A dependency is a temporary connection, a temporary relationship between the account DAO and an account. The account DAO doesn't have an attribute account, but load returns an account, and I don't show dependencies. That's why. Now, what is the responsibility of the account service? The first responsibility is, it is an entry in a complex subsystem. It's where you enter something complex. If you know design patterns, this is also called a facade pattern. And the easiest way to understand an account service is it's the reception where you enter. So let's say you work for a large bank, a large bank in New York. They have these huge skyscrapers, and assume there is no reception. Then the problem you have then, so exactly the same works for software, but here is the large bank in New York. Here's the door where you enter. Maybe there's 20 floors, and there's no reception, and you have to be there. You have a job interview or you work there, whatever. Now, all the outside customers, or all the people that have to be or visit the bank at a certain time, if there is no reception, they need to know where they need to be. So if you want a loan, you have to go to Frank at this room. If you want to change money, then you have to talk to Mary at this office. And if you want a mortgage, you have to go to Bob at this office. So all these people, they know exactly where to go to. Otherwise it will not work. Now what's the problem? There's tight coupling between what you have within the bank and the outside world, the customers, the visitors of the bank. Why? Let's say there's a reorganization in the bank. People retire, people get different jobs, people go to different offices, different floors are rented to different companies. Big reorganization. The only way that this still works is you have to update all your visitors, all your customers. You have to send them an email or whatever for every simple change. That's not handy. So we have tight coupling. What do we do? It's a very simple but powerful pattern. It's a service class. It's a reception. We put a reception here. So now we separated, we have now loose coupling between the outside world and the internal details of the bank. If there is a reorganization within the bank, the only thing that needs to be updated is the reception. Because people come in and the reception, they ask, I need a mortgage, where do I need to be? Oh, and this floor, this person. I need a loan, where do I need to be? So it's very simple reception, but very powerful. You get loose coupling between the internal details and the outside worlds. So the service class is exactly that reception. It's where you enter. And on the reception, you can ask anything that you ever would ask for a bank. They know about loans, they know about mortgages, they don't know about payments, they know about transferring money or whatever, different currencies, but they don't do it themselves. They send you somewhere. They delegate. The reception doesn't do bank business. It's exactly the same that the service class. The service class doesn't do logic, doesn't do business logic or any other logic, it delegates to other classes. So this account service class here, it delegates all the calls to the data access object, to EMS sender, to the account, maybe to a logger, maybe to a class that goes to the file system. It connects everything together, but it doesn't do the logic itself. That's where we have the other classes for. So then we get, again, single responsibility. The data access object only knows about data access. EMS sender only knows about sending EMS messages. The logger only knows about logging. That's the first responsibility of the service class. The second one, and that's I explained it already, it separates the plumbing from the business logic. The business logic, in this case the account and account entry, is not even aware that there is a database, or we send messages, or we do logging, or we check security, or whatever plumbing we need. It's not in the business logic. And that's, then again, we get loose coupling, and it's easy now to change database. It's easy now to change logging. It's easy now to change messaging. Going to a file system. Oh, the business logic is independent from it. I don't know if you know unit testing and how well that was explained, but we make a difference between unit testing and integration testing. In unit testing, you test one class in isolation, and in integration testing, you test classes together. Now, why do we make a difference? Because in unit testing is very fast. That's what a developer does on his or her own machine. Also in the test environment, but also on your development machine. Integration testing, you often need some middleware and servers and databases, etc. So you only do that on the test machine. Now, if I want to test the account here, maybe together with the account entry, I want to test this, and the deposit method would call the data access object here, and it would call the EMS sender. These are two plumbing classes. They are slow. They really go to the database. That's slow. It's called to Pluto. I really send a EMS message. It's typically asynchronous, so that's not so slow. But in a unit test, I don't want to go to the database. I don't want to send a EMS message. So what do I need to do if I do this? I need to mock this. You need a mock framework. And again, I don't go into details, but you need to do something extra to mock these relationships so that you don't really go to the database, but you call a mock class. So you have to do something extra. Your test becomes more complex. But if you don't do this at all, so this is not allowed, you don't need to mock at all. So if business logic never depends and never knows anything about plumbing, your unit test becomes simpler. It's easier to test, the test is simpler, easy to understand, easier to refactor, to change, etc. And here I have exactly the same class diagram, but the different layers, the 5 layers that we looked at. This is what the service layer is for. Service classes are in the service layer. It's where you enter. And you see here the methods in this service class. That is the logic that is, you could see this as a whole bank component. This is the logic that this bank component exposes to the outside world. This is what you can call on our component. So you see here actually, this is encapsulated here. The client, whatever that client might be, does not know anything about EMS sender, account DEO, account entry or whatever. It's completely hidden behind the service. And then here, you see the sequence diagram of how it works. I call deposit on the account service. What does the account service do? It delegates. First it goes to the DEO, says, load the account with his account number. That method returns the account. And then you say, deposit is the business logic. So create an account entry. So for deposit, the business logic is not so interesting. But if it's withdraw, I could draw the same diagram for withdraw. For withdraw, what is the business logic? How much are you allowed to have a negative amount? So how much are you allowed to withdraw? Can you have a negative amount at all? Maybe yes, maybe no. That's business logic, business rules. That's in this deposit method here on the account. That's the business logic, or in the withdrawal. And once we're done, the service calls the DEOs as well, save this account and send a message. So again, what you see is that account and account entry, they don't talk to plumbing classes. These are the plumbing classes here. Now for this example, I show a very simple, small scope of an application. If you have a very large bank application or a web shop or whatever, it would be exactly the same layers, but more classes. So let's say I also do a lot with customers. Add a new customer, remove a customer. Then I would have a customer service with a customer DEO. I do a lot with mortgages. Okay, I have a mortgage service and a mortgage DEO. And of course here a mortgage as business class and a customer as business class. And then maybe here there's a logger here and there's an email sender and or whatever. So it's the same structure, only you have more classes in a large application. Yeah, this idea clear? So that brings me to the first main point here, and the second one. The domain classes are never aware of technical or plumbing classes. This gives many different advantages, like easy to understand, loose coupling. Change is much easier because we have loose coupling. Testing becomes simpler, etc. By diving deep into pure consciousness, one gains support of all the laws of nature without needing to know or to be aware of all the different details of your life and your world. So we talked about it yesterday, about the complexity of creation. Now, to be, you want to be successful. Everybody wants to be happy in life. Everybody wants to be successful in life. I don't know anybody that doesn't want that. Now, one approach would be, okay, so then I need to know how life works and how creation works and how relationships works and how money works and how health works and how that all works. That means if I need to know all these details, and we talk about the complexity of creation, then probably I need to go to school my whole life and then still I don't know most of the details. But we have access to this pure consciousness where everything is in seed form, where you can access that intelligence of creation where if you access it and start living it, you spontaneously do the right actions and get the support that you need for happiness and perfect health and all these things and success in life. So it's like you call the surface layer. That's all you need to do. And all the details of whole creation is hidden. You don't need to know it, but it happens spontaneously. Yeah, there's again REST controllers. I'll get to that. But REST controllers is in the presentation layer, often called the web layer. Yes. Can you please clarify the need and importance of integration layer? Give more examples on what the integration layer is. I don't think I understand this layer. Let's park this question. When I give a real example in Spring Boot, we're going to build this, and then it becomes clear. The short answer to this question is, what is integration? That's talking to the outside world. This is one application that has to communicate with everything that's outside. So send an email somewhere that's talking to an email sender. Do a REST call to another application that's calling another application. Sending a message with messaging to a certain mailbox. Writing to a log file on a file system, or reading a file on a file system. All that logic is in the integration layer. That's basically what it is. You could also say, well, all the plumbing except data access goes in the integration layer. So if you have an email sender, in the integration layer. If you have a logger, in the integration layer. Now, we go quickly over these layers one by one, and then we're going to look at how are we going to build this really in Java, and we're going to use Spring Boot to make it as simple as possible. Could we define again what plumbing means? Technical code. Whenever you use a technical library, or, well, I could say technical code, I could also say anything that's not business logic. So logging, that's technical. You use a logging library. If you go to the database, you typically use a library. It's technical. If you call if you call a web service or you send a message, you use a library to do that. A technical library to do that. That's all plumbing. That's not why you built the system. You build a system for the business logic and the business rules, so that the business people can use the system for the business requirements. So that's the business logic layer. But presentation layer, there's also plumbing, because you typically use either a REST framework or a user interface framework or whatever. So everything that's not business logic is plumbing. So if we look at the presentation layer, there are certain design decisions you have to make. And one of the things is, where do I put my logic of my user interface? Do I put it on the client side or on the server side? And in the beginning of client-server architectures is that we have data in a database, and then we write applications, client applications that talk to that database, get data and show data, update data, etc. That were basically the first client-server applications. And the problem was that anytime we change the logic of our application, because what is the whole application? It's the client. The database is just plain raw data. When we change our application, we have to update all the clients. So in a large company, when we have, let's say, 10,000 people that use this application, we have 10,000 clients. If we make a change to that client, we have to update 10,000 clients. We have to deploy or install 10,000 clients again. So later on, we got the idea, okay, we have stored procedures in the database. I had that example yesterday. There's logic that you can write in a database. Then the client can be much simpler because we can put a lot of logic in the database in one place. So then if the logic changes, you only have to change the database and not all the clients. And there is, later on with the internet, we went one step further where we have clients in a browser, web pages, HTML pages. That's really a thin client. There's no logic at all in your HTML page. And all the logic is then in a server that talks to the database. Now, this also has disadvantages. So what nowadays is the popular architecture is, we also put logic in the client, in the browser, like the JavaScript frameworks like Angular or React or Vue or those kind of frameworks, where the whole application runs in the browser and then talks to the server, typically through REST, and the server can talk to the database. This is nowadays the best practice. Now, if you do the first, this one here, where you put all the logic on a server, then all user interface related logic, like conversion, validation, rendering, navigation, templates, security, etc., you implement on the server side. Meaning every action you do on the client side, every button you click, every hyperlink you click, everything you will do there, you have to call the server and you get an answer back. For many years, we use this architecture. But then especially Facebook and Google, they came with Angular and React and those kind of frameworks, where most of the user interface related stuff or web related stuff is done in the browser. And then only validation and security needs to be done on a server. Now, why would I do this? Why is this so popular? Well, let's say we have this application, Google Stock Watcher, where you have a certain list of stock tickers and you want to know what's the current price of every stock. Now, if I have a server-centric web framework like Spring MVC, Java Server Phases, the early ASP.NET from Microsoft, then if I click this button here, remove the stock JKL from my list, I will have to go to the server because the list is in the server side. So there's a network call, so it takes bandwidth, it's slow. If it is a client-centric application, the list is on the client side. So if I click that button, I remove it from the client side, I never go to the server. I still have to go to the server to get this data here, but that's different. So not for all logic, I have to go to the server. So these are Java frameworks, these are server-centric, these are JavaScript frameworks, they run on the client. Now, why? What are the advantages of these frameworks here? So you have less network traffic because you don't go to the server that often. So it's by default faster response times. Not for everything, like a shopping cart lives in a browser on a client side, not on a server. We have a separation of front end and back end. Different techniques that you use on the front end and the back end. Often different languages that you use on the front end and the back end. You can have a separate team that builds the front end, separate team that builds the back end, and they can work independently from each other. So it's again separation of concern. Instead of one large complex application, which has front end and back end in one, I separate it now. I have a simpler front end and a simpler back end. And they can work independent from each other. We can have different front-end channels. How you, let's say, the front end can be a web application, but can also be another application, a .NET application, or a Python application. It doesn't matter what it is. Maybe it's something that runs, an app that runs on a mobile. It doesn't matter. You just go with REST to the server, say, give me this data, and you get the data. And another, I don't have it here, but another advantage is it scales much better. That's an important one, scaling. Like we talked yesterday, scale up, like load balancing and those kind of things. And if you have a web shop and you do everything on a server, then all your shopping carts live on a server. That takes a lot of memory. So there's a restriction of how much shopping carts you can handle. How much shopping carts can one server handle? With the JavaScript framework, the shopping cart lives in a browser. There's no limitation of how many browsers you can have. Every user has his own browser. Can be 1 million, can be 1 billion. Nobody cares. In this case, for the shopping cart. That's why we separate that from each other. Service layer we looked at, it's like the facade pattern or the reception. It's the easy way to remember. It's a reception where you enter. Then we have a data access layer. So here you see the account, DEO has save account, load account, update account, delete account, find by name. And in this case, it should have an account holder or some name. This should then be find by account number. Now there are many different things we can look at if we go to the database. We have a whole lecture on that. I think lecture 4, lesson 4 is all about database access. So I go very quickly over this. So our application can call stored procedures that live on the database. But most of the time we don't use that anymore. That's an old technique. Typically we put business logic in the application, and the database is just a collection of data. There was this thin and thick client mentioned in previous slide. What does it mean? Okay, it means, it's already a few slides ago. A thin client means there's no logic in it, or there's hardly logic in it. A thick client, there's a lot of logic in it. That's what it means. How much logic do you have? If you have an HTML page, there's no logic at all. There's no loop, there's no if then else, there's nothing. If you have a JavaScript application, there are loops and there is if then else, there is logic, conditional logic, whatever logic there is, shopping cart logic. That's what we mean with thin and thick client. So I go over the data access and then we have a break. So stored procedures, they run in a database. Oracle has stored procedures. Some databases, they don't have it. Some databases have it. Postgres has stored procedures, but SQL Server, well, SQL Server also has it, but MySQL doesn't have it. There are many databases that don't have it. Yesterday, we looked at the example where you hide the data behind the stored procedures. So you can now loose coupling between the applications and the tables. Now, what you also can do is using in Java something like JDBC, what is basically logic where you send SQL to the database. So SQL is the language that the database understands. Do this insert, do this update, do this query, and give me the result back. The disadvantage of this approach is that your SQL statements are strings in your application, and you have many of them. I once spoke to somebody who said, I work on a large application, and we have this application already for 8 years, and we have 10,000 SQL statements in our application. And we had to change some table structures once, and it took us 3 weeks to get the application up and running with the new tables. Because they had to go over all 10,000 SQL statements and see if they had to change also. So you get coupling with, if you do this, that coupling between your SQL statements in your application and the structure of the tables and columns in the database. And then in Java, you have JDBC to do that. That JDBC is like an interface that your application always stores JDBC. Doesn't matter which database you use. And then you have a JDBC driver for a specific database. So you have the Oracle JDBC driver that translates JDBC calls to calls that Oracle understands. And I have here a MySQL JDBC driver that translates JDBC to calls that MySQL understands. Now there's another way to go to the database, and there's an object relational mapper. I'll come back on that when we look at databases. So I leave it now for what it is. I'll come back on that later. Okay, so this is a nice time for a break. So let's take a 10-minute break. Okay, so I missed some questions, so let's go over them before we continue. Where would utility classes be placed, like helper classes? It depends what utility classes they are. Do they have something to do with data access? Do they do something with integration? So that decides where they go. If it has to do with business logic, then they go there. If it is more something that the service class needs, we will see that later, then they go there. So it depends what utility it is. then is it okay to say a disadvantage of client-centric is security? Should we put the server as a single source of truth? Well, that isn't a disadvantage of client-side framework security, but most of the time that's not a problem. So you do check on the server side also security, and there are many solutions for that. So your REST calls, when you go to the server, there's where you check security. So most of the time that's not a problem. Can you please mention the major difference between architecture patterns and styles? Well, there's confusion there. Like model view controller. Some people call it a pattern, some people call it a style. Who is right? Nobody knows. So I don't care if you call it a pattern or a style, as long as you know what model view controller is. Layering, everybody calls it a style. Maybe there are some exceptions that call it a pattern, but it's typically a style. It's typically a style is at a higher level than a pattern. A pattern is typically one or two classes, but there are also styles that are just one or two classes. So it's not clear what is the difference. And I don't care if you call something a style or a pattern, as long as you understand the underlying idea and the problem that it solves. So styles, examples of styles are layering, microservices, hub and spoke. We will look at all these styles later. For example, component-based design is a style, object orientation is a style, procedural is a style, and an architecture pattern is then typically a data access object or a repository or a service class, or that are typically architecture patterns. Okay. So there are many different ways to connect two applications together. And some of them are old and not used and give tight coupling and it's not a good idea. And some of them are very popular. So the first one, RMI, that's a remote method invocation. That's a Java technique that in general we would call it a remote procedure call. This was very popular 15, 20 years ago, and even before that. Nowadays we don't do that anymore. So in Java that would mean you call a method of an object in another virtual machine. It's a remote Java call. It is really a Java call, so it's a synchronous call. So do the call and wait till an answer comes back. And because object B lives in a different virtual machine, if you do that call, you cannot call by reference that you normally do in Java. You cannot send a reference. Like if method X calls method Y and sends a reference, what's a reference is just a pointer or a memory location. Let's say this is an object here that has value X, and you want to send value X to method Y, then you cannot send a reference of object X. So the reference would be A3F9. That would be the memory location of X. Well, if you send A3F9 to method Y goes to that location, but there's nothing there. So what you have to do is call by value. You have to serialize that whole object so that you can send it over the network, and then on the other side you have to deserialize it. But this technique is old and is not used anymore. Why? Because you have tight coupling. If anything changes on the left side or the right side, the other side has to change. So it's tight coupling. You don't want to do that. It needs to be Java to Java. It's coupling on every different level. So that's old, we don't do that anymore. Underwater, there are certain proxies, stub and skeletons it's called, that do the real network transfer of data. But again, this is old. We don't do that. Then we have messaging. And in Java, we have a standard for that, JMS, Java Message Service, where you can send a message, like a sender can send a message, and a receiver can then receive the message. So it's asynchronous. The sender can just send, and the sender doesn't care if the receiver is online or whatever. It's like the mailman. Mailman doesn't care if you're home, just puts your mail in your mailbox. Mailman doesn't even need to speak your language. You never have to talk to your mailman. So you have also loose coupling between sender and receiver. The only coupling you do have is the message that you send, but not the person or not the sender. The receiver is independent of the sender. Now in JMS, there are two patterns, point-to-point and publish-subscribe for messaging. What's the difference? With point-to-point, you have a dedicated consumer for a message box, and we call it then a queue. The message box where the message goes into. This is the same as the message box in your home. If somebody or the mailman puts the mail in your message box, then we know you get the message, not your neighbor, because it's your message box. That's point to point. We also have publish subscribe. This is more like an email list or a WhatsApp list. You're a member of a WhatsApp group. And then you have publishers that publish messages, and then typically we call it then a topic, the mailbox. And a publisher publishes a message in a topic, and all subscribers get that message. It's like broadcasting. You only publish one message and everybody who has a subscription gets it. Very powerful. We'll come back on this later. This is very powerful. So that's messaging. Very often used because of the loose coupling. Very popular. Then we have web services. And web services, typically over HTTP, you call another service. We have in two flavors, SOAP and REST. In the beginning, everybody did SOAP. Nowadays, almost everybody does REST. With SOAP, the whole idea of SOAP is that if applications need to talk to each other, we have to make sure we use standards. That a Microsoft system can talk to an Oracle system, that they all use the same standards for whatever, for security or transactions or reliability or attachments or whatever. And it took a lot of time and effort to create these standards and to agree on the standards. But if you have all these standards, it also becomes more complex. And most of the time, you don't need these standards. So you don't need that complexity. So if I look at SOAP, it has certain characteristics. You go over HTTP and you send a SOAP envelope here. What's in the SOAP envelope? There's always XML. So SOAP always uses XML. And in that XML, you see you specify, for example, which method do you want to call. And then here is a products. So I call the method add products, and this is the products I want to add, data of the product. That's what I send to the service, from the client to the service. The service then looks at, okay, I have to call add method. It gets the product, it has to serialize it as an object, and then it will add that product to the list. Now, in this SOAP envelope, you can add all kinds of extra information about security, about transactions, about addressing, about reliability, about attachments, all kinds of standards. So this is, you cannot see the details, but this is a list of all kinds of standards within the SOAP standard that you can use. So you see for security here, transactions, resources, and here management, business process information here, and metadata, reliability. Most of the time you only want data. You call a service and give me this data or update this. You don't need to send security or transaction or business processes or all this kind of information. That's why SOAP is not so popular anymore. So what's the characteristic of SOAP? It's complex because it supports all these standards. And it has a certain way of how it works. And that's what I said, anytime you have something complex, it will be replaced by something simple. What's that something simple? That's REST. Nowadays, almost everybody does REST. Why? Because it's much simpler. In REST, you don't have all these standards for security and transactions, because you don't need it anyway. But in the REST, there are three important things for REST. So you always go over HTTP, and in HTTP, you can send a certain HTTP request. So HTTP is always a request response. Send a request, you get a response back. But the request that you send can be different requests. And for REST, we are interested in GET, POST, PUT, and delete messages. So you can send an HTTP delete message, or an HTTP GET message, or an HTTP POST message. And within HTTP, we have a certain agreement, certain standard that GET you do for retrieving data. If you want data, you do GET. If you want to add data, you do a PUT, or sorry, a POST, add new data. If you want to update existing data, you do a PUT. And if you want to delete data, you do a delete. Now, this standard works very well if your application, you really want to do GET, retrieve data, create data, update data, and delete data. But what if you have a calculator and you want to add and subtract and multiply and divide? What do you do then? Well, an important aspect of REST is that all the types of messages except the POST is what we call idempotent. What is idempotent? An idempotent message or idempotent logic you can call as often as you want without any side effects. So, and GET, give me data. If I call it once or 10 times, it doesn't, nobody cares. The data on the server side remains the same. If I delete data, if I send a delete message 1 time or 10 times, the end result on the server side is the same, because you typically delete it in the first call. The next call for the same delete, it doesn't do anything because it is already deleted. So if I send a delete message of the product with product number 3, if I send that message 1 time or 10 times, the end result is the same. If I do an update, a put, update the products with product number 5. Instead of $5, it now becomes $10. If I send that update call 1 time or 10 times, the end result is just the product is now from $5 to $10. The end result is the same. That's what we call idempotent. It doesn't matter how often you call it. But post is not idempotent. Anything that changes something on a server side, and if you call it again and you get a different result, it needs to be in a post. So deposit money, that needs to be a post. Why? Because if I deposit 1 time or 10 times, that makes a huge difference. Or withdraw money. Or if I have a stateful calculator on a server, stateful calculator, it has state. The current state is 4. And if I the client sends add 6. Well, if I send it once or 10 times, that makes a lot of difference. Because if I add 6 once or add 6 10 times, the end result of the calculator is different. It's a stateful calculator. If it is a stateless calculator, what does that mean? I send a calculation. I send 3 plus 5, and I get back 8. And then there's no state on the server. And I say 8 times 8, get back 64. Well, if I send 8 times 8 1 times or 10 times with a stateless calculator, then it is idempotent. So then I can use a put, for example. So we have get, put, post, and delete. So there's a question here, could we say GraphQL is also an integration possibility? If so, how is it different from the others? Yeah, I don't want to go into GraphQL because that is something you learn in another course. It's in the WA course. But GraphQL is basically using REST, where you have flexibility of defining queries. So it's just REST. So it's GraphQL also does use REST. Why put patch are idempotent and post is not? Doesn't put patch change the state? Well, there's a difference between what it does. It is what you can choose. So if the logic has a side effect on a server, you cannot repeat the same call multiple times. You have to use post all the time. That's basically it. So and the question is, why is it idempotent and post not? Because you can put an update the product with number 1 from $10 to $20. If I do that 1 time or 20 times, the end result is that it's $20. That's why it's idempotent. But if you have different logic that is not idempotent, you have to use a post. Then with REST, so that's the first thing you can look at with REST. The second thing you can look at is the URL. So it's basically the type of message, get, post, put, delete, and the URL that decides what you do on the server side. And I will show that in Spring Boot. So here, the idea is that I send a post request to this URL. So post basically add a new product. Which product? Well, I put the product data in the body of the HTTP request. So you can send data in the body. And then that product will be added here. And here I use XML, but typically you use JSON as format for the product. Here's an example with JSON. So I say post/product, and this is the product that I want to add. Then I could say get/product/ and then a product number. So this is a variable. I can put variables on the URL. Give me the product with product number A234. And what I get back in the response, the body of the response contains the product information. That's REST. We will build this, we will write this in Spring Boot. And again, I don't go in all the details of REST. I don't go much into SOAP because there are other courses that handle those. In WA, there's 2 lectures on REST. There's a lecture on GraphQL and all these details. Now, both SOAP and REST, what they do, if let's say we have Java applications, first we have a Java object on the client side. We make it into JSON or XML. We send it over to the server. The server deserializes it to a Java object, and then we use it. What you could also do is serialize the Java object itself, not serialize it to JSON or XML, but binary serialize it and send it over HTTP. But then you can only do that if both sides are Java or both sides is a .NET application. So this is basically a remote procedure call, like RMI, over HTTP. And this gives, again, tight coupling. If something changes on the client side, the server side needs to change. So typically we don't do that either. So if I look at the different possibilities, RMI gives tight coupling. We don't do that. Serialized objects over HTTP give tight coupling. We don't do that. Talking both to the database, we saw this yesterday, that gives tight coupling. If application A needs to change something in the database, application B needs to change also. And similar, if application A writes something to the file system and application B reads from the file system, tight coupling. If whatever you write or read is different or changes, both need to change. And in ESB, Enterprise Service Bus, we look at later, I think Friday. So what remains is then messaging and web services, SOAP and REST. Then SOAP is complex. I never met a developer that liked SOAP because it's pretty complex. So we don't want complexity. So there is a simpler solution, or this alternative, REST. So application A and B, if you want to connect them together, what is used in, let's say, 95% of all cases, is either messaging or REST. What's the characteristic here? So messaging has loose coupling, where REST has more coupling than messaging. Why? Because application B doesn't need to know anything about application A, and the other way around. Application A doesn't need to know anything about application B. With REST, application A needs to know the URL for application B, and it needs to know the message that it needs to send. a get, a put, a post, delete. How should the body look like? What should be in that JSON object? Now, if you look at messaging, A doesn't need to know the address of B or the URL of B. A only needs to know the address of the message box, the middleware where the message box lives. But there is always some coupling, and the coupling is the message that you send, the content, the structure in that message. That's the coupling between A and B. If A changes the structure, B needs to know about it, because otherwise B doesn't know what the structure is, what it gets in. Messaging is asynchronous. Application A just fire and forgets. It sends the message and forget about it. It doesn't need to know if B is online and who is B or how many listeners we have. Asynchronous. You don't have to wait till application B gets the message and does something with it. With REST, it's synchronous. Application A sends an HTTP request, has to wait till an HTTP response comes back. Now, another thing that you have with messaging is a buffer. You have a mailbox. That's handy sometimes. Like if you go on vacation for 2 weeks, that's handy to have a mailbox. What if you don't have a mailbox? That means the mailman, there's no mailbox, so the mailman rings on a door, you open the door and you give it. That would be the REST solution for mail. And you only get the mail when you're home and the mailman delivers it to you when you open the door. But when you go on vacation, that's a big problem then, because you lose all your mail. You depend on what the mailman does with all the mail. But now you have a mailbox, and if it's large enough, you stack up all your mail, and after 2 weeks you come home and you can look at your mail. So you have a buffer with messaging. You don't have that with REST, that buffer. If B is not online, then A has a problem. A gets a timeout. A has to remember that I got a timeout. Have to try it later. So there's a lot of work for A. And that buffer, that middleware, is an advantage and a disadvantage. The advantage is you have a buffer. The disadvantage is you need middleware, which is a server, software, that you need to start, that you need to stop, that you need to monitor, etc. So there are different servers like ActiveMQ, RabbitMQ, those kind of servers where you can define message boxes. Now, you don't need that middleware when you have REST. REST is just HTTP. There's no middleware. And with REST, you have less standards if you compare it with SOAP. But typically, you don't need these standards. So, messaging, because you need middleware, is typically only used within an organization, within a university, within Amazon, within LinkedIn, within Uber, within, I don't know, a library, whatever, within an organization. There's no organization that says you can call functionality from us by sending a message to this middleware. Now, between organizations, it's basically always REST, or SOAP, but mostly REST. So between organizations, you use REST. You can use REST anywhere, from front end to back end, from system A to system B, from organization one to another organization. You can use it anywhere. But we will look at that later. That loose coupling is an important one. That's why messaging is these days, especially in microservices, more popular than REST. Okay, so we see now, if you have one application, we apply layering on the different layers. There are different choices that you make, different databases you want to call, different ways you want to go to a database, different ways you want to integrate with other systems, messaging, REST, and there are different ways you do the web layer. So either you have a JavaScript that runs in the browser, or you have a server-side web framework like Spring MVC, and service classes, that's the reception, and then the domain layer is the business logic. Now we're going to build this in Spring Boot. So probably some of you have already seen Spring Boot in another course or outside the university. For some of you it will be new. And Spring Boot is a framework that makes it very simple to write an enterprise Java application. And because it makes it simple, it also hides a lot of stuff. It also looks, if you see this for the first time, it looks a little bit magical. How can this work? I put some annotation somewhere and it works. So the nice thing is it's simple. I only have to write some annotations. Spring Boot does the rest. But it looks a little bit magical. And I try to explain a little bit of what happens. So what Spring does, why is it so simple? It uses a technique called convention over configuration. It has a lot of conventions built in. And if you follow the conventions, you don't have to write anything. If you deviate from the convention, you have to add some more configuration. The same is used by Maven. You all know Maven. In Maven you have a POM file where you define your dependencies, etc. Before Maven, you had Apache Ant, which was also a build tool. And in Apache Ant, you have to define in XML anything you want to do. So the build file in Apache Ant in XML says, create this directory. Copy all files that end on .java from this directory to that directory. Then clean this directory. Then compile whatever is in this directory in all subdirectories. Then copy this file from that directory to that directory. Then do this, then do that. So it's a huge XML build file because you define exactly what needs to be done. In Maven, that build file, that POM file, is much simpler. Why? Because it uses convention over configuration. Maven has a lot of conventions. What directories do you use? If your project uses exactly the directories that Maven expects you to use, you don't have to put anything in the POM file. But if you use different directories, you have to put it in the POM file. And the same idea is what Spring Boot does. Anything that is a convention, you don't have to write. Now, we saw already our layered architecture. And now the questions about the controller. There were some questions people talked about the controller. The controller for REST, so REST controller, lives in the web layer. The controller talks to the service. Service talks to repositories, and in this case an email sender, and to domain classes. Now, the domain class here has a different color. Why? Because the domain class is a Java class, not a Spring Boot class. The yellow ones here, the controller, the service, the repository, the email sender, we call them Spring Beans. These are classes that are managed by Spring, by the Spring framework. Spring will instantiate these classes and connect them together. Like normally in Java, what you're used to is that you instantiate classes or objects and connect them together by calling setters. Spring Boot does that for you. So I just see a question here. Professor, can you clarify the idea of serialization? Well, serialization means a Java object is just something binary in memory. That binary you cannot store. That same binary structure you cannot store on the file system. You cannot send it over the network. What do you need to do? You have to serialize it. What does serialization means? You have to put it in a certain structure that the network, that you can send over the network, or that you can save on the file system. That's serialization. So you can serialize it to binary. You can also serialize it to JSON. You can serialize it to XML. So you have a binary Java object. I serialize it to JSON. I send it over the network, or I store it on the file system. I store it on a database. And then, let's say I send it to another application. The other application gets the JSON. I have to deserialize it. I have to translate JSON into a Java object or in a .NET object. That's what we mean with serialization. Something you can send over the network or store on the file system or store in the database. Okay, so we're going to build this. Now, one important technique that Spring Boot uses is dependency injection. What is dependency injection? It is wiring objects together. That's what is dependency injection. So typically in Java, you create classes and you connect them together. You do everything in plain Java. If you have a framework like, I don't know if you have seen unit testing. So in a unit test, basically what you do is, let me show that. I think you've seen it in NPP, but I'm not sure. If you do unit testing with JUnits, what you write is you write your test class. So you write a class. In a class are methods. So let's call it, I call it test method 1. And there's another one. I call it test method 2. And in there are tests. So here's the body, the test. What do I do if I use JUnit, which is a framework? I put the annotation at test on the methods. And then I say run. Run this class as a JUnit test. What does JUnit do? It instantiates the class, makes it an object, and calls every method that is annotated with test. That's what JUnit does. And then you get to see your test results. Often frameworks are in control of your code. Spring is in control of your code, of your Spring classes that you write. Spring instantiates the classes and connects them together. So if you have two classes, A and B, so I have class A, class B, and class B has to talk to A. So it has an attribute called, let's call it C1, and it is of type class A. There's an attribute with a setter, for example. So what do you do in your main? You instantiate A, you instantiate B, you say On B, you say set C1 with whatever you created with the object that you created with A. And now, so you instantiate A, instantiate B, and then you, with the setter C1 call points to A. This is what you do. Spring does all this for you. You just annotate the class with an annotation. That can be a service or a controller or a component. Let's call it a component. Add component. If I do this and I run my Spring application, Spring will instantiate class A and instantiate class B because it sees, hey, it's a component. Then what I do, it's no space here, but I put here the annotation add auto-wired, which basically tells Spring auto-wired, or the attribute C1 should point to the object of type class A. And Spring says, yeah, I have an object class A, so I make sure that this points to that one. And that's what we call dependency injection. Spring wires objects together. So here what I want to do, I have two classes here. Actually, I should say two objects. A customer service, impl, and an email service, impl. And I want to wire them together. Why? Because if I call add customer on the customer service, it wants to call send email on the email service. So the customer service needs to know the email service. How do I do this? The first thing I do, I have to make them Spring classes with this annotation add service. Spring says, hey, this is a Spring class. I will instantiate it. Here also, hey, this is a Spring class. I will instantiate it. So Spring creates the customer service and the email service. And then it sees here add auto-wires. And you can put the auto-wire on a setter. And what will Spring do? It calls the set email service with as parameter the email service that it just created. And then here they are wired together. This is what we call auto-wiring. They are wired together. So now the email service points to the attribute email service, points to the real email service object. That's dependency injection. So I can put the add auto-wired on the setter. I can also put it on the constructor. That also works. So Spring will call this instantiate the customer service, and then as a parameter gives the email service. And then here they are connected together. And what you also can do, and that's what we will do, the most simple one, you can I will finish this and then with a question. You can also put the add auto-wires on the email service attribute. And then even though it's public, even though it's private, Spring can just set, it uses reflection in the water. Reflection is a technique that you can do all kind of fancy stuff in Java. It will set, Spring will instantiate the email service, instantiate the customer service, and make sure this email service points to, the attribute email service points to the email service object. Okay, question?
Sorry. Yeah, how about if we don't do this auto-wired? I don't understand what this auto-wired injection is. I know this service, but what's the necessity of this auto-wired injection? Thank you.
Well, if you take it away, so if you remove this auto-wired, then what is email service then? If I print the email service, what would it print?
I thought that when we call this email service, it's automatically calling that without that
No.
auto wiring. So this without auto wiring, it will not work. That it mean?
Now, if I take away the annotation that auto wires and I print the email service, it's null. NULL. That's Java. If I don't instantiate something, if I have an attribute which is not a primitive, it's null. Meaning, if I call add customer, I have a null pointer. That's the answer to your question. Why do we need the auto wiring? So that Spring really sets that email service pointing to the object. Okay?
Okay.
Professor, question.
Yeah.
Do we need to use AutoWire when we're doing injection using constructor?
You can use constructor injection, you can use setter injection, you can use field injection. It all works.
On the previous slide, when we did the constructor, we used annotation AutoWire. Do we really need that AutoWired annotation above that one?
Oh yeah,
Yeah.
it's the same thing. If you leave this auto wire off, meaning, well, in this case, you will get an error from Spring because it cannot instantiate the customer service because it doesn't have a default constructor. But even if it has a default constructor, then the email service will be null because it never gets set. And then you get a null pointer here. And in the previous slide, if I don't have to add auto wired on the setter will never be called. At least if you don't call it. Spring will never call it. And you get a null pointer exception. So yes, you do need to add auto wired. Clear?
Thank you.
So dependency injection, it's a technique to wire objects together. If Spring controls your objects, instantiate your objects, then Spring is also the ideal candidate to connect them together because it has control of all the objects. That's why we do dependency injection. And it can also give flexibility. So again, if you take the enterprise architecture course, they spend, I don't know, 2 or 3 lectures on dependency injection. They go very deep into it. We're not going to do that because this is more an architecture course. But it's a technique to wire objects together. The Spring makes heavily use of it. Everything in creation is connected with everything else in its source. That's where we connect. The unified field, the home of all the laws of nature. And if you are in unity consciousness, you experience that you experience that connection. You are not different than anything else in creation. You have that same, share that same source with that intelligence that you can make use of. So, the controller is a Spring Beam. We annotate it, we will see later, as REST controller. The service, we annotate with as service. Repository, we annotate with at repository. These are Spring annotations. The email sender, typically at component. And then we use auto wiring to connect them together. Yeah. This is all dependency injection. But the domain class is not a Spring Beam. It's a Java class. And no Spring annotations. So the details we will look at after lunch. So now we do the meditation and then we have lunch. After lunch, we go over a Spring Boot application with this dependency injection. And then we also add some messaging. And that's the similar thing we will do in the lab in the afternoon. We built our own small Spring Boot application with REST and dependency injection and messaging. Okay, so let's first do the meditation. So make yourself comfortable.